Hey, what's up guys? So in this video, we're gonna go over some questions in this worksheet, which we didn't have time to do in class. So let's get started. Question number 3. For this type of question, we know that the idea is to get rid of any complicated things in this expression by using Taylor series, so that we can write everything in terms of polynomials only, which is going to be easy for us to simplify later. So let's write the square root of 3 plus 4 cubed as 3 plus 4 cubed raised to the power 1 over 2, so that we can make use of our template 1 plus x raised to the power m equals sigma m from 0 to infinity mn x raised to the power n. But before we apply the template, we know that there's usually some adjustment to be made, because our expression does not look exactly the same as in a template, because there's a 1 here and then you don't have a 1 here. So let's make up a 1 by using factorization. Factor this 3 out, we're going to have 1 plus 4 divided by 3x cubed raised to the power 1 over 2. And then we distribute that 1 over 2 over the product. So that is 1 over 2, and then 1 plus that, 1 over 2. And then the expression we have right now looks exactly the same as the expression in the template, where our x is this one, 4 with 3x cubed, replacing this x. And then our m is this 1 over 2, replacing this m. Okay, like that. So we're gonna replace that expression with the summation in the template, and then we have sigma n from 0 to infinity, the right hand side expression, where in this case m is 1 over 2. So we're gonna write 1 over 2 n, and then x is gonna be this one, 4 divided by 3 x cubed bracket raised to power n, which we can do some simplification. So simplify that as 1 over 2 n, and then 4 divided by 3 n x cubed, that is x raised to power 3n. Okay, so far we have successfully written this out by using Taylor series. Now this is already turned into a summation of some x power. So our next step is going to use that expression to replace the expression in here. So this one is gonna be, I have no idea why I cannot copy this one only. Try one more time. You see that? Right? Copy the entire thing, but I just want that one, not the entire thing. Okay. So we will replace that with this expression, which is this one, and then minus square root of 3 divided by x cubed. And you probably have noticed that there is some cancellation for us to do here in the summation, because when n equals 0, the first term is going to be 1. And after you distribute this square root of 3 over the sum, you can cancel this square root of 3. So let's write that out. By plugging n equal to 0, we can write out the first term, which is 1 over 2, 0, 4 over 3 raised to the power 0, and x raised to the power 3 times 0. And for the remaining terms, we're going to continue to use the sigma notation to write that out, which is going to be the same, except that n changes from 0 to 1. So that is how we write out the summation. And then minus square root of 3 altogether divided by x cubed. Sorry, I'm blocking a little bit. And then we're going to do cancellation. Because by definition, 1 over 2, 0 is 1. This guy is also 1. X raised to the power 0 is also 1. Right. So we have 1. That's the product. And then we're going to distribute this 3 over the sum, over this term and this term. So that this term is going to turn into square root of 3, which cancel with that. And then we're going to be left with the summation only, which is square root of 3 summation 1 over 2n 4 divided by 3n x raised to the power 3n divided by x cubed. Okay? And because this x and x, they are the same, right? And when you have the same base and then you do the division, you can just subtract this exponent from the exponent on the top. So we're going to subtract the exponents, which leaves us to this 1 over 2 and 4 divided by 3 and x raised to the power 3 and minus 3. And then we take a look at our original, what the question says. The question says x approaches 0, right? We know that when x approaches 0, everything that has power x, I mean x raised to some positive power, is going to go to 0. For example, x squared, x cubed, x raised to the power 4, all those x power is going to go to 0. So it's important for us to consider what kind of power we have in here. For example, when we plug in n equal to 1, we see that our first term is actually a constant, because 3 times 1 minus 3 is going to be 0. And then starting from the second term, you're going to have some x raised to some positive powers, and those terms going to go to 0 afterwards as x goes to 0. So we're going to write that out, write out the first term and the remaining terms. So that is by plugging in n equal to 1, we have 1 over 2, 1, and then 4 over 3 raised to the power 1, and x, 3 times 1 minus 3, right? And the remaining term is just the same thing, except that n changes from 1 to 2. So we have sigma n from 2 to infinity. My screen just turned dark for some reason. Okay, I have resetted it. So that is what we have here. And then, as I said, you're going to have some x raised to some power here. So for example, when you plug in n equal to 2, you're going to have x raised to the power 6. When you plug in n equal to 3, you're going to have x raised to the power 6. So let's just write that out to avoid some confusion. So that is, we can actually calculate this. this is 1 over 2, 1. That is by definition 1 over 2, right? And then there's 4 over 3. And then x raised to the power 0, which is 1. And then plus, in the summation, for example, the first term is going to be 1 over 2, 2, and then 4 over 3, 2, x raised to the power 3 times 2 minus 3. That is 6 minus 3, x cubed. Okay? And the next term, we plug in n equal to 3. So that is that. And then x raised to the power 3 times 3, 9. 9 minus 3, that is 6. Okay? Just to show you that if you write out a sum, you're going to have some kind of x raised to some positive power in the summation, which is going to go to 0. Okay, let me just try to move it a little bit to the left side so I'm not blocking it. Right. So we know that this guy's going to go to 0, this guy's going to go to 0, and all of them is going to go to 0 as x go to 0. Okay. So this entire tail is going to go to 0. And then we're going to only be left with the first term here, which is our limit. So the last step is just to claim that the entire thing is going to go to the first term, which is this one multiplied with 1 over 2 times that. That is 2 divided by 3, which is square root of 3 times 2 divided by 3. That is 2 divided by square root of 3. As x approaches 0. I do have a reminder for you. Some people tend to write the equal sign, but in here we cannot write the equal sign. That is because this one is not directly equal to 2 divided by square root of 3. And instead, 2 divided by square root of 3 is the limit. So we are supposed to write an arrow here, indicates that it's a limit as x approaches 0, instead of directly equal to. Okay, so that is how we solve this question by using Taylor expansions. It's quite tedious, you can see, right? And then recognizing, knowing to use this template is very easy. And then the technical stuff here is to make the adjustment before we use the template. And then there's something for you to notice, which is when n equals 0, the first term is a constant, which you can use to cancel with this term. And after that is canceled, there's some power for you to divide, and then just some messy algebra. And then we do need to notice that after we do the division, the first term is still a constant, so we need to write that out because that is different from the other terms, which all goes to 0 as s go to 0. Okay, if you have any questions, let me know.